Mr. Ambrose has a bachelor's degree in electrical engineering technology from the DeVry Institute of Technology and an MBA from the University of Denver. Before joining Lockheed Martin, he was vice president of space systems for Raytheon Command, Control, and Communications business segment. Mr. Ambrose joined Lockheed Martin in the year of 2000, and in 2013, he became the executive VP of Lockheed Martin's Space Systems. Lockheed Martin's space system products include major systems for satellites, human space flight, strategic and missile defense, satellite command and control, sensor and data processing. Let's welcome Mr. Richard Ambrose.
Great. Thank you, Dr. Hsu, for that kind introduction, and I'm so grateful to have the opportunity to be with you here today. Now, I do have the fortunate luck, beat skill any day, of having several things going on today. First of all, it's like National Star Wars Day, I think, or something. So I went around talking to folks, not one person said, "May the 4th be with you." So I don't know what that meant. And I think everybody knows what tomorrow is, right? What is it? Well, yeah, but it's also National Astronauts Day. So I tried to recruit somebody, but it's also Cinco de Mayo. I agree with that, to have fun. So we did go online, kind of like, what's going on at the university today? We didn't find anything until tonight. You guys had a lot of parties going on tonight when we looked at social media, at least I think you do. At least it said you did anyway. But if you work for Lockheed Martin, you could go enjoy those parties because tomorrow's a 980 day off at Lockheed Martin. So every other week you get a 3-day weekend. So that's a shameless pitch to have you look at us when you get ready to graduate. All kidding aside, the Lockheed Martin's been in the Santa Clara County here since 1956. When they moved the Missile Systems Division up from Southern California up to Northern California. Now, I know how some of you are thinking, and no, I was not alive in 1956, but neither was Silicon Valley, right, because it hadn't really got its start. But because of the work we did and the demand we put on microelectronics and things to do some of the systems we needed to do, helped seed what became Silicon Valley, with many others, of course, in the area. Now, Lockheed Martin is a combination of Lockheed Aircraft and Martin Corporation, which basically are formed in 1912. Martin was started in a church with a plane, encouraged back in the day by Orville Wright. If you look at Lockheed, the two brothers were great mechanics, did seaplanes and broke all kinds of overwater flight records just down the road here in San Francisco before the two came together. So we've had a long-standing relationship here, and with your university, we hire more university grads than any other school as we're present here in the Bay Area. We're still about 5,000 strong, in the area here. So enough with the history, and we'll move on and kind of talk a little bit today about what are we going to do in the space sector. Why space? I hope you get some time in between, your homework or studies and things, but you ever been out and there's not a lot of city lights and just looked up? And sometimes those stars are so close you feel like you can touch them. Isn't that quite well? How they get there? How old are they? How they form? How does this all work? Well, that's the spirit of that discovery and innovation that we're about. And how do you enhance the human knowledge to understand what that is? Space also helps drive economies and global economies because it's a global nature in many nations, as well as supporting global security, as you kind of saw in that video as we go forward. Space Foundation has reported that it's about $323 billion global market in space. That's a large economic impact, and it's growing as we go forward. Now, last 5 years, there's been about 900 new entrants into the space industry. That generates a lot of vitality and energy, and clearly innovation in both technical as well as business innovation that's going to be required. So the real question then is, for a company like Lockheed Martin, 104 years old, publicly traded, and there's clearly differences, right, with startups that might be singular focused or trying to move forward. You'll hear a lot of terminology of space 1.0, 2.0, some of my employees say 3.0. You hear new space, old space. These are really false dichotomies. We don't even allow that, within Lockheed Martin. The real issue is, how do you innovate and how do you stay relevant? Whether you're 6 months old or 104 years old, it's all about reinventing yourself over and over and driving that through innovation. And that's what we're here about today, to kind of talk to you briefly in our short time together, is how are we going to do that? How do we drive that innovation in a couple areas? So I'm going to hit about 3 targeted areas. The first area I want to talk about is additive manufacturing or 3D printing. As you can see on the screen here behind me, what's critical about this is that this allows us to create geometrically complex systems and hardware that you cannot machine, or you cannot, a technician cannot drive in a machine. Why do you do that? We get an order of magnitude less mass that we need to go into space, more complicated designs, better ways to transfer heat or loads through the system, and allows us to shorten timelines. So if you kind of look in the back chamber there, you'll see a propulsion tank being assembled. If we machine that normally, it could take up to 2 years. Under 3 months, by doing additive manufacturing, putting it together. It is powerful. It's productivity. It helps us, kind of create that future and significantly reduce cost. The second area I'm going to talk to you about is kind of moving from manual processes in digital. And if you read anything, we're going through a tremendous change right now in the industries of digital transformation. We call this a digital tapestry in Lockheed Martin, and basically it's digitizing from end to end, from the way you can have a concept and design and move through, validate the design in a virtual space before you ever do hardware, all the way to operation, sustainment, including driving that technology and that digitization down the supply chain. Imagine a world where a supplier to us could envision a design, send it to us, right? I would say maybe email it to us. It's probably going to be in a cloud anyway, and we probably would just pull it down. We could validate that design, let them know it's sound before they ever build it, and we can merge this into 3-dimensional space. You're seeing an employee here work in what we call CHILL, which is a computer-human lab, interactive lab. Sorry, I dropped the I, not enough coffee today. And what we do, that you can actually go in and experience, the technician engineer can be an avatar in the design. And we can watch how that gets built in a three-dimensional kind of space. And by the way, this comes from all you gamers. This comes from all the game industry. A lot of that software that comes in to help facilitate that. And you can even go through the designs as if you're in an MRI or a CAT scan. For instance, our Orion spacecraft we work with NASA on. You can go in and look at that structure and look for any issues or incompatibilities or changes. So it's extremely powerful. And then if you have issues, you can, it'll help you resolve as well. We had a satellite that had a problem with a computer board buried deep in, and we had to replace it. If we went through the normal process, we would have had to remove that, taken many units off, 70 connectors apart, and rebuild that satellite. Would have been 6 to 12 months delay. Because of this, we could go in, the software would go in, actually cut a hole through a structure, get the card, replace it, put it back together in a much shorter time. So it's very powerful. And then finally, want to go streamline some of our operations. So we have to use the efficiency of all of what I just showed you in kind of driving our next generation technology and satellite. We call it a 2100 TR, if you will, a tech refresh, how we modernize that satellite. In this case, we drove commonality. If you go back in history of satellites, there was a lot of tradecraft or single-purpose designs. The reason was it was very hard. And as this industry is moving forward with innovation, now we're trying to put more commonality in here and reuse and digital so you can reprogram things. So you get effective scale and shortened timelines. We want to shorten timelines 25%, cost 35% with this satellite as we go forward. And we're hitting a lot of those. This satellite's now being used both commercially and for the United States Air Force programs as we move forward. So those are three major areas that we're working on and that can enable us. But more importantly, with this modernization, we have to find a way to innovate and innovate quickly, safely, and affordably for all of our customers. There's tremendous pressure, obviously, on all the budgets. You know, pick up a paper any day of the week and you can see that. So we have a special obligation at the scale of Lockheed Martin that we have to find those solutions. So let me now talk about a few fun things to kind of put out there for you. You may have seen in the press, a big splash in the press last year, Juno, 8,000-pound satellite, traveled 1.7 billion miles to Jupiter to go, you know, help the NASA scientists understand Jupiter and everything going on, the most radioactive planet in the solar system. It's flying close enough to be within 3,100 miles of the cloud tops and kind of survey that area. So it's pretty exciting. And if that's not enough, I mentioned 3D printing earlier. This is the first planetary satellite that we actually 3D printed parts. Now, we start small. We just do support brackets for waveguides and things of that nature, but we think it's the only 3D printed parts that have traveled 1.7 billion miles. So, but we're challenging everybody else to say, we can beat that. So I think it's a great example of the creativity and the partnering we do, because anything we do, we're partnered with, in this particular case, was NASA JPL Laboratory and others, because they're going to do the hard, and the principal investigators do the hard science as they bring that in. You see behind me now then, actually one of the most close-up and most detailed images taken of Jupiter by that satellite. It's a better image has ever been taken from Earth or even another satellite. And it's taken a little bit west of the Great Red Spot if you look at the planet. And it's just quite impressive, giving more data to the scientists as we move forward. So moving on from Juno, I want to talk about another spacecraft, and I have to use my cheat sheet here because all you engineering students, if you just learn acronyms, you'll sound brilliant in any company you get hired into. So this one is Origins Spectral Interpretation, Resource Identification, Security, Regolith, Explorer. Or just say OSIRIS-REx or OREX, we'll know what you're talking about. What you're seeing here is a Colorado-based employee, Jim Harris, who created this tag sim, we call it touch and go sample acquisition mechanism. He did it in his driveway. This is how innovation happens. And I heard he did it with his son. Now, I've never asked Jim the question, but I was wondering if his son actually kind of came up with this design a little bit, and he went and worked it. But he's one of our great engineers, contributes a lot. So this tag SIM is going to come in and actually get 2 to 70 grams of material off the asteroid Bennu. Now, we launched it last year. It's taken 5 years kind of running around to catch this asteroid and get this sample. We're going to sample that asteroid without landing on it. So you see the simulation of that arm. That arm's going to come down. It'll hit it, it'll blow some nitrogen gas, it'll pull some material up, put it in the return canister, and then send it back to Earth. So you get a lot of creativity, a lot of discovery, a lot of exploration that we can go do. Working across, with the NASA and other partners, and of course NASA works with the European Space Agency as well. So a lot of science going on, and it's exciting. And I'll leave you as I move on to the next topic, but one thing, if you're not watching the news, watch it. A week doesn't go by where NASA scientists aren't writing about another discovery. For those of us in my age group, we were all raised, there's no moist, Earth had the water, there's no other water out in the solar system. They're finding water everywhere now as they figured out how to look. And where there's water, hopefully there'll be life. So hopefully in your lifetime, you'll see that discovery. So bringing it back a little closer here, another program we're proud to have is the GPS-3 program. This is the United States Air Force program with a global positioning system. I think you should be very familiar with that. You use it every day if you don't know that you do. But anyhow, this is part of a worldwide constellation for GPS satellites. We're finishing up construction of the first satellite that we're going to have here. And then we have another 10 behind that in production. This satellite will be 4 times more accurate and have more power. What that means to you is if you have problems and you get down in the downtown areas and cities and you lose some signal, having more power and signal accuracy and stuff will help in that kind of area. 200 suppliers in 29 states help us build this satellite or contribute parts with this satellite. So we're pretty excited about this as we go forward. We get that first launch off soon. Now I did see again, if you guys are walking out to one of your Cinco de Mayo celebrations and your iPhone takes you the wrong place, it's not our satellite. It's your map app. All right, a satellite's fine. Bringing a little closer here is SBIRS, space-based infrared system, built about 15 miles up the road here in our Sunnyvale campus. SBIRS, think of it as it's built for the United States Air Force, and whether you're sleeping or in day, it is doing constant watch at a global basis for any kind of infrared incident, such as if there's a missile launch or whatever, and inform the military commanders and the political leaders of what's going on a global scale. Very, very capable system. Also, we work with the government to look at other uses for this. For instance, looking at any kind of weather phenomena and even forest fires that it can track and help with that kind of help citizens with early warning detection and natural disaster kind of relief. And then finally, speaking of weather, the Geostationary Operational Environmental Satellite, R series, which is GOES-R, we've recently launched. And this is one of 4 satellites that'll be launched they'll help cover the Western Hemisphere to watch for weather. So again, you look on your TV news in the evening, you see a weather image or whatever, they usually coming off one of the GOES series of satellites. We're especially proud of this satellite because of a lot of the new capabilities it has. Has a lot more sensitivity. It's about 5 times faster in refreshing what's going on in the cloud activities and things in space. And there's a very unique instrument just built down the road here at Palo Alto by our Advanced Technology Center called the Geostationary Lightning Mapper. This is incredible, and we're really hopeful with this because if we can operationalize the science and get the algorithms right, they believe we can give advance warning as much as 10 minutes or more of a tornado. Now we're going through all the calibration process. So what you're seeing is a storm line here on February 14th in Texas. So from 22,000 miles up with a system built Palo Alto, but also by many, many small companies. Some as far away as Tustin, some close by Sonoma, doing optical filters, optics, lenses, focal planes, to help us produce that. As a matter of fact, the top 10 small companies around California is about $40 million worth of subcontracts on this. But if this is accurate and we do this, hundreds of lives can be saved. And that's what makes every employee of our company come to work every day, is the protection of lives. And that's what space can do for you. So with all that technology, one more, Suvi, sorry. What's very important, the other instrument we have on here, we like, it sits out on the solar panel, and it's the solar ultraviolet imager, and it looks at the sun. Because if the sun gets active, it can play havoc with power grids, satellites, cause a lot of disruption. So you see different channels and different angstrom or wavelengths across there that it's looking at. Look for a coronal mass ejection. That basically think of space weather versus Earth weather and what's going on out around the planet, and then also the affect things here on the planet. So another very powerful instrument, also built out at our Advanced Technology Center. So again, with all that technology, it's great, but fundamentally, technology doesn't just happen. It happens through people, because people innovate, right? And you're part of that. You may just be studying, and you may say, why am I taking this class? But it's worth it, because if you can have an effect like this, if you can take a global system and help save lives, make it better for people, I think that's powerful. And I would encourage you to stay the course, finish up college. Again, we recruit more San Jose State grads than any other school in the area. Matter of fact, two of my direct report executives are alums here and go there. And it's just, you can have a lot of fun here, regardless of what you want to do, or you can be an astronaut. I was trying to recruit someone to apply for astronaut training earlier here, but I wasn't winning. But if you think about that, we're at the cusp, and it's powerful, and it's drives the economy, and follow your passion. If your passion happens to be in this area, I'd lean forward, and please, the more you can do to help people in STEM and things, it's a great cause. So with that, I think I thank you for your time, and I'll open the floor up for questions.
Is a space act here?
Oh,
is SpaceX a competitor?
SpaceX a competitor? Yeah. SpaceX is a competitor for launch of United Launch Alliance. For a lot of launch there. A competitor in, we like the fact that many new entrants actually stimulate growth, stimulate innovation as we go forward. So I think it's a big universe, and there's plenty of room for more.
I had a question. What percentage of the satellites you make are for planet exploration or water detection on other planets?
What percent of satellites are for exploration?
Planet exploration or water detection on other planets.
Oh, to find water in other planets and stuff? Percent of satellites made? Basically, it's our planetary, if I understood the question right, what number of how many the satellites?
Like how many satellites you make that
can do that?
Yeah.
That's a good question. I don't know if I have an exact number. About 15 to 20% of what we do is in that particular area, the number of satellites. So we tend to launch, I'm going to say at least 1 to 2 a year, give or take. That's not exact. They're doing some kind of planetary mission, right? One I didn't mention there, for instance, MAVEN, which is a great mission that's up and trying to understand why did Jupiter lose an atmosphere. I'm sorry, Mars, thank you. I got corrected, thank you. We have to I apologize, Mars, sorry, what happened in the atmosphere around Mars, and it's studying that with a lot, and just, so what happened there, and could it affect us here on Earth, right?
With driverless cars in development, there's bound to be more demand for satellites, since a lot of these driverless cars rely on GPS navigation. But there's also got to be a lot of competition for these satellite bids. Do you have to be cutthroat about getting these bids between other competitors, or is there room in the market?
That's a good question. It's always competitive, by the way. There's a lot of capacity in the industry, so it's competitive. The real, opportunity I think we have, what you're talking about with driverless cars or even the Internet of Things, or anything about mobile, satellites can have a big play in. And so there's a lot of new architectures actually forming on the books that can create a lot of new opportunities. We'll see which one of those kind of play out. But it's opportunity, but no matter what, when you have a good industry, has a lot of, attractiveness because of its growth, you're going to attract a lot of competition, and not just from U.S. firms, but globally. So it is competitive.
I had a question. Hi. When you're dealing with technologies that are developing really fast, like additive manufacturing, how do you deal with things like certifications and testing standards, and that sometimes may not keep up with the technology?
Yeah, that is an excellent question. That is the biggest worry bead we have. So what's interesting about this is, our industry space isn't really driving the additive manufacturing per se, right? The bigger volume production, think automobiles, airplanes, those kind of industries are spending billions in that area. What we do is we take then the technology they've developed, and right now is why we're going slow. You saw us, we've worked on this for 7 years. We're actually modifying the printers to do what you're talking about, the certifications and how do we test. One of the things we found is a lot of the printers didn't actually measure down the exact amount of material that they printed out or laid down. So we've been using advanced optics and things to cert this. So how do we do real-time quality control and can measure it as it's laying down the material? So those are, areas that were going real slow. You saw us in the propulsion tank. You saw it at half. We'll do 2 halves and weld, which is the way it's done today. We just print it faster. First some of the engineers said, what if we can print the whole sphere, right? And we couldn't get in to test it. You couldn't measure wall thickness of the titanium because that's a propellant tank and things. So and then when we ran, we did some burst testing on it. We actually found that it had some gaps and flaws in the material. So that's why we've gone to the 2 halves, and we're really working on the best way to measure that, insert that. You're absolutely right. Yeah.
How long would one of your satellites? Thank you. How long would one of the satellites that you discussed take to design and then build and then go up? Is it a matter of years, a matter of months, or?
It's years. So typically when we're almost like a made-to-order, type of business when you do a contract. So, on the short end, figure 3 years. On some of the planetary, that's at the real short end to 5, and some have taken longer. But 3 to 5 is the range. Now what we're trying to do is shorten that. And so how do we configure to order? And so if you look commercially and things, how do you get it down to 18 months? Which drives that commonality we talked about earlier. So the more you can have common parts you can put together, you can accelerate that timeline.
Hi, Rick.
Hi.
Yeah. Do you have does the Lockheed Martin have any new businesses with China, the People's Republic of China? Thank you.
Actually, one of our other business areas is doing work with China on process on with their nuclear reactors and that kind of process. They're deploying many of those for their energy issue, and they're doing some work with them there. We do not out of the space systems part of it.
How much of Lockheed Martin's business? How much is Lockheed Martin's business is from government, and how would that the new administration? Do you think that will affect that part of business?
I don't. I'd say about 95% of our business tends to be with the U.S. government, or with its allies that the government supports, right? So if you look at us, we're about 20% would look international, but it's with products we would sell to the U.S. government. And I don't think, it's hard to say what the administration is going to do or not do this early in. So.
Hello, I'm an electrical engineering student here, and I just wanted to ask, when you're looking for interns, what particular characteristics do you look for in the person?
That's a good question. We hire a lot of interns every year, and we like to bring in, once we get an intern, we like to make sure we can try and hire as many when they finish up their degree. But clearly characteristics, we'll look at your first year or two grades, and we'll look at, can you learn, contribute, show up on time. No, I'm kidding. But part of it is we actually employ our interns in very real world challenges and things, right? And frankly, some of the interns have come with a very creative solution. So we really like plugging them in, getting our programs and working through that. So like anybody, any employee, you look for, commitment. You look for, wanting to engage and diving right in and learning, because this industry, it's all about lifelong learning, right, as we go forward. So I think that's key. Want to add anything, John? No? Oh, ability to work with people. I asked if I missed something from we have your executive liaison here, so I said ability to work with people, the other thing he added, so yeah, that's a good one.
Hi.
Hi.
Sorry, I was wondering, so in terms of government issues, do you ever face a time when you're working with a new project or new works and the legislation is just taking too long to institute that policy? And with that being said, how do the international laws play into that with, say, countries that don't have those limitations?
Let me make sure I got the first part. So if we're working with the government, you say, and there's a legislation required and it takes too long?
Yes, because
Yeah.
it automatically takes, you said about 7 years to develop that satellite, and then the
Right.
additional probably 3 or 4 years for government policy to be instituted. How does that take a part into the industry in terms of international competitors?
Yeah. Well, if I got that right, let me answer a couple ways. The first one is, if there is a government program, we know way in advance through the processes of the acquisition cycle of the government agency, what they're trying to do, because they come out with requests for information and things. The Congress has to fund and make it a program element right in the budget. So that tells you it's coming, and then they'll run an acquisition, a competition, down select. So that's a fairly long process, so it's easy to see. Now, when you move out to international, other countries all have different approaches to acquisition, right? Some countries will use private-public partnerships more. Some will use a direct commercial sale for airplanes or satellites. Some will actually want to, do more with the United States government and a government-to-government relationship, if you will. So we have to be flexible to handle that full spectrum. When it comes to conducting business, though, we have to respect the laws of the land of any country we're operating in, or in any differences in states, because states have different regulatory policies and things. So we have quite a few folks that are in that realm that study this, and we use that to help set our policies up within the corporation to assure we're compliant with all those. Yeah. I don't know. I'm not tired yet, if that's what you're asking me.
Hi, it's me again. I just wanted to ask, just trying to get a perspective of what exactly you do. You're the vice president. Do you get to work on the projects like on hand, or maybe I should ask, how much time do you spend working versus at meetings?
That's really a low blow. I don't get to play with hardware much anymore. No, it's, when you're early in career, that's when you're learning the most and you get to do real hardware. And my staff knows when I've had enough meetings, I'm like, I'm going down to the factory. I can't take it anymore. I'm going to go see a satellite. We're going to go work. And I'm going to go talk to the people and stuff that work on it. So at my level, you don't get to, you don't do much engineering. You don't do much hardware design, build or anything. That's a true statement. But you get exposure. You get to work, there's 18,000 people in the space organization, and it's 18,000 people that make the company work, right? Make space work. And everyone's different and unique, but everyone works together, and it's an exciting to see that power. So when you get in leadership, it's no more about doing yourself. You have to be energized by enabling your people to perform and seeing what they can do and how they conquer things and perform. So that's a transition. You don't have to face that for a very long time, but and some people don't want to do it. Some people, we have employees, 40, 50 years, they can't get away from the hardware or the design. They'll stay there. But a company like Lockheed Martin can support all that, right? In many different careers, disciplines, moving around. You do satellites, you want to do aircraft, you want to do ships. You can move around in a company like that and make sure, biggest thing I say is always be learning. And, but yeah, thanks for reminding me, I do a lot of meetings.
What made you want to go to space?
Maybe, the question was, because they didn't have a mic, what made me want to go to space for the camera there. I was always enamored with space. As a kid, I watched, the astronauts walk on the moon. And I had this vision by the time I'm my age, we'd be buzzing around the cosmos. It didn't quite work out that way. So my hope is with all this innovation, everybody coming into space, and stuff, we'll get there now by the time Europe at my age. Happens faster than you think, by the way. And stuff, but we just look at space and the possibilities and what's out there and the discovery. I mean, we're human beings. We're designed to discover. Whether you're going out in the cosmos or the next medical breakthrough in a lab, right? We want to learn and discover, and whatever that passion is, I would just tell you to follow that.
So besides space satellites and space exploration, what do you think is the future of Lockheed Space? What's beyond that?
Beyond exploration and satellites and, well, we want to do more satellites. We want to work with NASA, and one of our programs we have is the Orion. So that's about doing manned exploration, out with space and things of that nature. But there's many things we're doing with whether it's next generation navigation systems or next generation weather sciences. We kind of, work that whole spectrum.
Great. Yeah. So who usually develops the software on your satellites? Is it in-house, or do you outsource them to other companies?
A lot of that work is done in-house. The software work. Because the software and the satellites and things are core. Now, in some cases, we do outsource some, or especially if we're buying some type of avionics from another provider. Let's say they already have software that does something we need. We'll buy that, but then when we integrate it, we have to pull it together with everything and make sure we can test it and simulate it end to end. Right.
So with satellites, and I know with like working with like the Air Force and everything, satellites that are able to detect, let's say for like enemy missile launches or something like that. In the future, do you think there would be a defense satellite capable of potentially destroying something like that in midair, something about like that?
Probably not a satellite, right? There are a lot of treaties and stuff that prevent that stuff, right? So, but you know, clearly the beauty of satellites, as they remote sense the Earth, they keep coverage, and we have total awareness of what's going on, and more importantly, we have attribution to who does what, right? So I think that information is important. And more as we move forward, there'll be more and more, we call it democratization, right? More different, more countries are getting, being space-faring nations, and more awareness. So I think that's a good thing to make sure we stop the bad actors.
Last question.
Great. Okay, well, let me thank you. No, let me thank you for your time. I enjoyed meeting a few of you. A couple exchange students here. It's great. Enjoy your education, and thank you for taking the time today.